So, there is variation. In fact, it is a good question that you asked. This Sulbasutras, certain constructions which are described in later, people call it later because, so the language is somewhat more refined. See Vayam, Mayam, Guna, etc. So, it is more explicit, right. So, in this connection, so it is stated that Katyayana comes little later. So, the one of the interesting constructions which Katyayana gives is not to be found in Bodhayana. So, they have also evolved over a period of time, and more sophisticated constructions have been given which are not to be found earlier. So, this gives us the clue that, so this should be done at a later stage, having given more thought about what can be done. So, this Katyayana Sulbasutra, I will give you very interesting example, and the special construction, so which I would like to highlight in Katyayana Sulbasutra is this: to construct a square, that is n times a square. So, n times the area, see that is what we want. See, the sutra goes like this: Yavat pramanani samachaturashrani eki kartum chikirishet eko nanitani bhavanti tiryag dvigunan ekata ekadhikani trisrir bhavati tasyeshu tatkaroti. So, yavat pramanani samachaturashrani eki kartum chikirshet. Yavat tavat means as much, so much. So, this itself actually gives you a clue of the concept of algebra. See, in mathematics, normally when we teach children, we start with arithmetic. Arithmetic means fixed numbers. So, at a later stage, when we move, we say x, y, etc. See. So, let this be x, let this be y. So, x can be anything. So, then yavat tavat comes. So, as much, so much. So, this actually is a very important clue from the viewpoint of history, that these people, the demonstration that I am going to show here now gives you a very important clue, that they have made use of algebra, they have made use of geometry in a very sophisticated way. So, let me just explain in this. See, yavat pramanani samachaturashrani eki kartum chikirshet. So, you want to combine them. Suppose let us say n squares we want to combine. Now, what should be the side of the square which has n times the area of these small squares? This is a problem. So, how do you find out? So, you know for sure that if you choose the side to be root times n, suppose the square is a, then root n into a into root n into a will give you n times a square. So, how do you find root n? See, root 2 also you say 1.14 etc. How do you know? You do not know. So, there should be a way by which you can easily find the measure. See, you do not have sophisticated device to do sophisticated calculation, but you should have some very intuitive way of arriving at it. And this intuitive way and simple way is what can be employed by everybody. See, not everyone will be expected to do this sophisticated mathematics, even if you have a measure or method to find out to root n. So, root 25. So, root 23, suppose I want to find out, there may be a mathematical sophisticated method, but that cannot be employed by everybody. So, therefore, very nice simple technique has been presented here, but you cannot present this technique unless you had that sophisticated mathematics already done. This prescription which we find here, so cannot be done. See, for instance, suppose you look at this, unless they had done this kind of equation in some form, they would not have been able to give this prescription. This is the claim that I am making now. See, what he says is ekikartum chikirishet ekonani tani bhavanti teryak. Ekonani, suppose yavat pramana is n, Ekavona means n minus 1. Eko nani tani bhavanti tiryak. Tiryak means always horizontal. So, what you have to do is, so suppose you know n, so n can be say let us say 23. Now, what you have to do is n minus 1. So, 23 minus 1 should be the measure. So, this you can fold, see 23 times a rope and then you can get it done. 22 times you stretch this. Eko nani bhavanti tiryak. Then he says Dvigunan ekada ekadhikani trisrir bhavati. See, ekadhika is n plus 1. So, that you should actually do it in a two-fold way. See, n plus 1 should be taken and that has to be divided into two halves. So, then what you can do is mark the middle point, stretch it above, put these two ends here. So, this time this side will be n plus 1 by 2, this side will be n plus 1 by 2. So, now what you have is a triangle, trisrir bhavati. See, that is what he says. See, Dvigunan ekada ekadhikani trisrir bhavati. Now, he says tasya ishuhu tat karoti. Tasya ishuhu tat karoti. Ishuhu means this, see, the perpendicular dropped from the vertex to the base. See, konat atra madhye yat patati tasya ishuhu iti nama. So, now he is saying this gives you tat karoti means whatever number you want. So, what happens is, see, this will give you the value of root n straight away. So, this mathematical construction that you have very simple. So, you have the number n. So, you take n minus 1 measure rope, you take n plus 1 measure rope. So, then you construct a triangle like this. Okay. Once you construct the triangle like this, so you drop this and that will give you the value of root n. So, this is a very interesting and sophisticated construction which they have given. See, what kind of mathematics has gone behind it? See, that is what is really appreciative. See, atra pashyatu. So, what has to be done is, see, so here in this you know AD square, see AD square. So, that Sulbasutras theorem tells you. So, it is basically AB square minus BD square. So, AB square, see in this diagram is n plus 1 by 2 square into A square minus, so BD is n minus 1 by 2 square into A square. Okay. So, what you get is basically, so once you do this little algebra and finally you will get NA square. So, NA square is AD square. So, AD is nothing but root times n into A. So, that basically that segment gives you the value of root n. So, n is anything. So, this actually tells you, see in fact today there is a lot of discussion which is going on among mathematics teachers. So, there are international conferences which are organized on how to make mathematics much more simpler and interesting, because a lot of people get this phobia of algebra. See, moving from arithmetic to algebra. So, International Congress on Mathematical Education, some 2000, 3000 people will come and discuss. So, one of the problems that they find is the moment you go from arithmetic to algebra, it is one level of abstraction. Abstraction, it is in this sense, you deal with x, y, etc., which has no magnitude. So, this is one level of abstraction. Now, if you analyze this carefully, this particular sutra which has been given to find the value of root n. See, root n, finding the square root of a non-square number is straight away difficult problem. See, suppose you want to say, I want to find out the value of 123, I want to find the value of 327. So, how do you go about? So, there is a systematic way in which this systematic way has been described by Aryabhatta later, but in the times of Sulbasutras, so which is far 1000 centuries before, 1000 years before Aryabhatta, say 800, 500 BCE. So, how did they know? If you look at carefully, this prescription cannot be given. See, take this as n minus 1 and divide this n plus 2 by n plus 1 by 2, make it a triangle and then this will give you, unless you have this equation in mind. So, this actually speaks of the real sophistication of mathematics around the Sulbasutra period. So, this speaks of not only geometrical constructions, but also the algebra which has gone behind the geometrical constructions. So, this is something which we need to keep in mind when one makes assessment of the mathematics, the level of mathematics that has been there in the Sulbasutra period. So, this is something which you do not find in other Sulbasutras. See, Katyayana Sulbasutra gives this kind of prescription to find the value of root n. See, some scholars opine that the statement of Pythagorean theorem could simply be based on empirical knowledge. See, empirical knowledge means you do it in a few cases and then based on that you generalize it. See, so without knowing proof, but this kind of geometrical construction which has been given by Katyayana cannot simply arise out of empirical knowledge. See, this is in general, you have taken n plus n minus 1. The succinct description only means that the Sulbakaras could do fairly sophisticated mathematics of turning an algebraic equation into a beautiful geometric construction. See, this is what is very interesting. You have an algebraic equation solved, that you put it into geometrical construction which can be used by anybody. See, that is the kind of interesting thing. So, the other words, the unstated algebraic principle has been cleverly implied to solve a very practical problem of finding the value of root n. Why am I saying it is a practical problem? It is practical because you want to know the construction. So, what amount of space is required for me to accommodate so many people? This is a very practical use, see, not necessarily yaga. Considering the fact that genesis of algebra was yet to take place in a formal way centuries later. Algebra as such, if you look at when as the evolution of mathematics in general. So, it is something which is quite difficult to make an assessment and a lot of people still have a problem with algebra. So, this is something which should have been in practice. So, what we should infer here is unless this way of doing some algebraic equation has been there in the society, it would not have been possible for these people to use this algebra to arrive at this geometric construction prescription. So, that is something which is very important. So, with regard to the Pythagorean theorem, so it is very simple for us to see. If you go back in the previous slide, see, unless you know Pythagorean theorem in general, this is not possible to construct. See, this prescription implies that they knew Pythagorean theorem and cleverly making use of that theorem with the specific numbers to get this value. So, this is a very important thing that one has to note. So, they have also given various other prescriptions as to how to transform a circle into a square, square into a circle. In fact, this is not a problem which is ever possible to be solved. So, to construct a square whose area is exactly equal to that of circle is an impossible problem to solve. Why? Because of the number of pi, the number mysterious number pi which is occurring. But this problem seems to have been attempted by some people and some constructions have also been prescribed here. See, Chaturashram mandalam chikirshan akshnayardham madhyat prachim abhyapataged yadyadati sishyate tasya sahatritiyena mandalam parilikhet. So, this is something which has been stated. See, sahatritiyena means take 1/3 of it. See, suppose you have a square and what one has to do is one has to take the diagonal and with the diagonal you are asked to draw a circle. Once you draw the circle, so from this side to this point, so there is something which exceeds and whatever exceeds you divide by 3, that is what he is saying. See, yadyad atishishyate tasya sahatritiyena mandalam parilikhet. See, so take 1/3 of it and then draw a circle. So, this blue circle which you find here will be approximately having the area of this square. See, the accuracy you will be able to straight away see here. See, the value of pi which will give you the accuracy. See, if you actually calculate, so it turns out to be I think 3.088. What you require is 3.14. See, 3.14. So, it comes to something 3.088 kind of a thing. So, if you do a little mathematics, so you will be able to get that. So, that is the prescription that has been stated here as far as this construction is concerned. But what is quite impressive in Sulbasutra, another aspect is this sutra. See, this we find in the context of evaluating the value of root 2. Pramanam tritiyena vardhayet tacchaturthena atmachatustrimshena vunena savisheshaha. So, what is very important here to note is the word savisheshaha. See, what we need to understand is, in mathematics there are two types of numbers. One is called rational, the other is called irrational. And of course, we have further classification later, transcendental, complex and so on and so forth. But in general, this is introduced at the school level. Rational means a number whose magnitude can be represented by the ratio of two integers. Irrational means you cannot, right. Any of the non-square numbers, if you want to find the square root, it turns out to be irrational. These irrational numbers have to be represented as rational numbers in some approximation. So, this has been attempted by Sulbasutras. See, for instance, for root 2, root 3, why were they interested in it? They were interested in it because of the kind of alter construction which demands that. I will give you an example, but this sutra is something which is very, very peculiar and very interesting. Why interesting? Because I will tell you. See, if you look at this, it says pramanam tritiyena vardhayet tat chaturthena. Tritiyena vardhayet means 1 by 3. Tat chaturthena means 1/4 of that. Then atma chatustrimshena vunena. See, minus 1 by 3 into 4 into 34. So, what you will find is, in general, so you will find some pattern. See, 3 into 4. Next number is 3 into 4 into 34. In the next thing, if you go, there will be minus 1 by 3 into 4 into 34 into 1154. So, this is a general prescription, but if you do up to this, then you get reasonable accuracy. See, it is correct almost 6 decimal places, this value of root 2. So, this is a very fast converging series, and unless you have a certain geometrical construction in mind, it will be impossible to give this kind of a prescription. So, that is something which is quite noteworthy, and this word savisheshaha means visheshena saha vartate etadeva iti ma chintayatu yad uktam maya tat savisheshaha bhavati, means you will not be able to give the exact value. So, that is indicated by the word savisheshaha. So, the recognition that a non-square number, when you try to extract the square root, is not going to be exact, is something which is hinted by this sutra. That is all I am saying. So, this is a very important aspect. So, to think of the sophisticated mathematics which was there around that period. See, how did they arrive at it? So, some interesting construction like this can be taken and then demonstrated as to how one can arrive at the value of root 2. If you try to find out, you will get some 3.000883. So, this is the value, and certain other interesting constructions which one finds in Sulbasutras is Shena Chiti. So, how do you construct this? So, there are a lot of constraints which are put on the construction of this. See, it will say that the area of this has to be some units, and the number of blocks that have to be used in constructing this should be this certain number. So, with the constraint of the area, with the constraint of the number of blocks, with the constraint of the shape of the blocks, to get something is not some simple thing. So, these constructions, if one carefully analyzes, in fact, when I had been to Belgium, so one of the scholars there, mathematicians, so he gave this as a very important assignment to the school children. So, we do not teach this, but he said that children are quite excited and they learn a lot of things from this. See, this is a very practical application of geometry, certain algebra, certain calculation, arithmetic, everything goes in. So, when we simply do dictate them some theorems etc., without any application, so they do not actually have a feel for it, and this person has constructed various models, he has given various projects to school children, in fact high school children. So, that is something which was quite interesting for me to learn. as to how they have been seriously interested and made use of the Sulbasutras to teach mathematics. So, we have completely ignored it. Anyway, the other last point which I wanted to say here was, so they also talk about what kind of material has to go into preparing these bricks. See, if you have to make this constructions, so you have to actually pile the bricks in different layers and how to pile them. So, all prescriptions are there. Parnakashaya nishpakva eta apo bhavanti sthemnen veva. See, the kind of thing that you have to add to the clay, there are certain extracts which this prescribe. So, that actually gives you very strong bricks. That is first thing that he says. Parnakashaya nishpakva eta apaha. The apaha that you add to the bricks, you have to parnakashaya pakva, certain parnas you have to make use of that. That is one aspect he says. Then he says ajalo mai sagum srijati. If you look at from the viewpoint of a civil engineer, then you really understand the importance of this. So, when you actually put fibers into this, so then that gives you enormous amount of strength. Samsrijati means mixes. So, it is like a reinforcement that one talks about. Then Sharkara Shmaho Rasaha Tena Sagum Srijati. So, add that all of them are to give much strength to the brick. So, Mukhya Bhasmana Samsrijya Ishtaka Karayet. Nowadays, we talk about this cement being done with ash. See, ash based cement, that is what is Bhasma. So, add to that. When you do that and then heat it to a certain temperature, it gives you certain interesting properties. So, the point is, I mean, they have experimented quite a few things. Then he also says, Ishtaka Shoshapakabhyam Trimshan Manatu Hiyate. It is also very interesting observation. Shoshapakabhyam, see, when you actually make it dried, then what happens is it has some contraction. Shoshena Pakena cha. When you do this, Paka is taking it to some 1000 degrees and so on. It reduces by 1/30th is what he is saying. Trimshan manatu hiyate. See, the volume will get reduced because of the reduction in the length and breadth. And how much does it reduce? He says roughly 130. Trimshan manatu hiyate. So, these are things which have to be taken into account. The point is the following. What it turns out to be exactly depends upon the kind of material that these people used, but an estimate of this has been made is something which is quite important to know that how carefully and how sophisticatedly they devised their measures to get the exact volume. So, that is what is very interesting to note. See, sada chatri chakram bhagam ishtaka rasate. See, somebody else says trimshakam bhagam Ishtaka hrasate krita. Once you do this, therefore, tavat samadhikam karyam karanam samamichhata. If you want to see to it that the measures are perfect, then calculate it and then appropriately you design your bricks. So, yet choshapakabhyam pratikhraset purishena tat sampurayet purishasya aniyata parimanatva. So, another way of doing is you fill it with some mortar, but anyway take the measures. Another important thing that he says is Bhedan Varjayet. So, when you try to put the blocks, normally the bricks are not aligned in the same level. See, they have to make it 5 levels. So, then he says the next level the bricks have to be put at the joint. See, the joint cannot be in the same thing, in which case everything will collapse. So, that is what he is saying. Uttaradharayoho Parshva Sandhanam Bheda iti upadishanti. What is this Bheda? Parshva Sandhanam. So, that gap. Then he says Amrinmayibhihi Anishtakabihi na Sankyam Purayet. This is also very interesting prescription that when you want to construct something, it should be of the same material. So, if you put different kinds of things, then it does not gel well. So, therefore, he is saying this Amrinmayibhihi Anishtakabihi Sankyam na Purayet. So, use the same kind of material. So, all these point to the fact that these constructions which have been prescribed, see, more or less all are planar constructions, and these constructions speak of the kind of the sophistication, the care that these people have been taking in trying to construct the Vedic altars as prescribed to the minutest measure, that 120 to 130 will reduce, therefore, you take care of it. So, the precision with which they wanted to do is something which is really noteworthy, and all the Sulbasutras speak of this, and though the Sulbasutras do not explicitly give the proof is somewhat implicit. So, as I was trying to tell you, the transformation from one geometry to other geometry, combining two geometrical figures, etc., everything speak of the sophisticated way by which they have been able to do this. Extensive application of the theorem is also found. So, this is something which is very important, and it has been sort of oral tradition which we have to keep in mind. So, not every detail will be presented, particularly in those days. The sutra style is very old, and regarding the antiquity, so though Babylonians by 2nd millennium, so had the triplets listed, but they do not have the general statement. So, therefore, I would say that if one wants to look at the antiquity of this fundamental theorem in geometry, I repeatedly say this fundamental theorem because if we look at some of the proofs which are sophisticated proofs, even while discussing a recursive relation of sine function, it is basically this which goes in. So, if one looks at from that viewpoint, it is a very, very important theorem. People do not even know whether Pythagoras was really associated with this. If you look at some of the careful historians, they do not use the word Pythagoras, they use the word Pythagorean, which means related to Pythagoras. Tasya shishyena kenachit kritam iti evam suchayanti. The Sulbasutra text primarily meant to assist the Vedic priest, but they actually give a variety of very nice geometrical constructions which have been employed for various purposes. Rathachakra chiti, Shena chiti, Kanka chiti. So, each has its own geometry, but the number of bricks will be same. So, it is a very challenging problem which has been posed, and this actually is the only text that is available for us to have an understanding of the kind of arithmetic, algebra or geometry which was prevailing in the Vedic period. So, this is something which has to be very clear to us. So, Vedas as such give only list of numbers. These texts which have been composed as Vedangas help us in trying to get the geometry which has been prescribed in Vedas. What one has to understand is, they have not been prescribing some geometrical construction which is not in Veda. So, the link between Veda and Vedanga and the Sulbasutra should be very clear. So, these are texts which have been formulated by people in order to help the Vedic priest construct his geometry. The geometry is prescribed by Veda, and therefore, so one tries to understand the connection between them and how these texts are related to the Vedic literature. So, later other texts like Aryabhata etc., they are more to get the planetary positions. So, they are not directly linked with the constructions which have been prescribed in the Vedic literature. So, Vedahi yajnartham abhipravrittaha, this yajna requires construction. So, this construction requires certain geometrical principles. So, this is something which is clearly established by Veda and Sulbasutras in connection with Shrauta Sutras, Grihya Sutras and so on. So, this speaks of the development of mathematics in the antiquity, particularly the use of arithmetic algebra besides geometry. See, the expressions used by the Shulvakaras for expressing surds, by surd I mean a non-square number, square root of a non-square number, in terms of the sum of the fractions lead to remarkable accuracy, as I told you up to 6 decimal places. The use of algebra is also very clearly seen from certain constructions. For instance, the root n which is obtained by geometry by Katyayana Sulbasutra. The different chitis not only speaks of the aesthetic sense, but also of the creativity and ingenuity of the Shulvakaras, and to work with several constraints imposed. So, this is something which I did not really highlight. If you look at, so this is the second layer of Shena chiti, then also the number has to be 200. See, the first layer of Shena chiti, there also the number has to be 200, but these are all different layers. So, one has to design the bricks. So, for instance, in this the head is 14 bricks, the wings is 108 bricks. See, if you go to the next level, the head is 10 bricks and the wings are 110 bricks. So, then only they will be sort of arranging themselves to give a stable structure. So, the archaeological excavations seem to have revealed that Shenachiti was constructed around 200 BCE. So, this is the earliest archaeological evidence that we have with respect to this. Dhanyavadaha.